morning, good afternoon, and good evening to everybody across the Asia Pacific region. We have Raymond again with us today, and he will take us through a deep dive of using Geocoder and search APIs provided by Here Technologies. All right, Raymond, if you can give you a quick introduction to people about who you are, and you can start the webinar. Over to you.
Thank you. Again, good morning, good afternoon, bonjour, ni hao, etc. I hope everyone is having a good day. Today, I am going to be talking about geocoding and search, or in other words, basically, what's there. So my name is Raymond Camden. I am a developer evangelist for Here. If you have any questions about what I'm showing today, if you want to talk more about the demos or the APIs or anything, you can go to my blog, www.raymondcamden.com. I have a contact form on there. I am also on Twitter at Raymond Camden, and my DMs are open, and I definitely don't mind you reaching out and asking a question. So again, I only have about an hour or so to show a bunch of stuff. If there's anything that you want to see more of or want to get a copy of the code, just drop me a line and I will be very happy to help. So the basic game plan for this session, I'm going to talk a bit about the prerequisites that you'll need for everything I'm showing today. I'm going to talk about the features at a high level and then show lots of code in terms of how to actually use what we're talking about. Now, in terms of prereqs, it's not too difficult. You do need a developer account, and that is free. You don't need to give us a credit card number. It's totally safe to sign up. And then once you do that, you will need a key, and I'm going to show you where that key is in a second. You could start over at developer.here.com, and you don't have to copy that URL. If you go, like I am right now, if you go to developer.here.com, you'll see a sign up button in the top right corner, and you can just go there real quick to get started. Once you do have an account, you will be given a project, basically for your free tier. If you go into that particular project, you will be able to look at and work with your keys. So in this case, I'm showing an example of the JavaScript keys. We also have REST-based keys as well. And you can see they are hidden on screen, but you can click to view them and click to copy them. Everything that I'm doing today will require either a JavaScript key or a REST key. And I want to point something out. I'm going to go back to JavaScript keys. So one thing that the JavaScript keys do is that they allow you to create a domain whitelist. So that means you can use those keys in a client-side application. Somebody can view source on your page and see those keys and take those keys. But if you have a domain whitelist, then they can't use those keys elsewhere. One thing that we don't make very clear, and this is going to be fixed hopefully pretty soon, is that the JavaScript keys with the domain whitelist can also be used for any REST-based APIs as well. So you can essentially create the JavaScript key, set up your domain whitelist, and I recommend adding localhost so you can test things locally, obviously, and then your proper domain, and then again, if somebody gets those keys, they won't be able to do anything with it. And basically, before we start working with the code, get the key, put it in a local file so you could test, and then start with that. So at a high level, and I'm going to take a pretty big feature set and kind of boil it down to a couple simple high points. Everything I'm talking about today falls into a couple buckets. The first thing is going to be, where is a particular thing? Where is New Orleans? Where is so-and-so store, etc. The flip side of that, and then what's at a location? What building is there? What street is there? And kind of the third bucket that we'll talk about is given a particular location, let's say, where I am right now, I want to find things that are around me. And that could be finding anything. It could be finding something within a particular category. For example, I may be looking for a gas station or a EV charging place or a Chinese restaurant. Basically, what can I do to find things considering that I am at a particular location? Everything that I am talking about today will be supported with REST-based APIs. That means you could use any language at all, so Node.js, Python, PHP, etc. It's also supported in our JavaScript library, and specifically our maps.js library. So I should point out that obviously JavaScript can make HTTP requests. So you can hit our REST-based APIs in a client-side application just like you could in a Node.js application or PHP, etc. But if you're already using our mapping library, we have services in there that makes it easier to use the stuff that I'm talking about today. We also have Android and iOS support. So again, all the features I'm showing today, if you're building native applications, you can make use of that as well. I will be focusing on just doing REST calls and showing JavaScript examples. But again, just remember that for native apps, you will have the same abilities to work with these features. So in terms of where is it? Where is a particular thing? We refer to that as geocoding, or if you want, forward geocoding, although honestly, I've never heard anyone call it that. And this is the idea of, given an address, a place, a locality of some sort, an administrative area, if you want to be formal, where is that particular location? And one of the cool things about our geocoding APIs is that the input can be imperfect. And the example I have on screen there, where you may have the right street, you may have the right city, but you put the wrong postal code, our API is actually going to be pretty forgiving about that. And that's great because typically you'll be taking, regular person's input, passing it to our APIs, and having it be, a little bit more loose will allow you to still help that person find what they're trying to find. So this particular API, it begins with this URL, geocode.search.hereapi.com/v1/geocode. I'll point out everything is in documentation. I will show you that more towards the end. But we have both a tutorial type documentation as well as full API references to guide you through all the features and stuff like that. That's the base URL. You will pass that key, API key equals whatever your key is. And then lastly, you will pass a value called Q, which will contain the input. So for a real example of that, real except that I'm not showing you my key, I could say, I want to geocode where Lafayette, Louisiana is. So I'm going to show you an example of that. And I'm going to show you with a tool called Postman. And I want to point out that in about an hour and 20 minutes or so, the next session in this particular hackathon, we have a whole session just on talking about how to use Postman. It can be a bit overwhelming at times, but it's also a really powerful way to test REST APIs. And so in fact, most of my demos today are going to be in Postman, which means I don't have to fire up a web server. I don't have to write Node.js or anything like that. I can literally, paste in a URL and set some values and then see what it returns. So I will do that. I'll hit send and we will see the data. So I searched for Lafayette, Louisiana, and I'm just trying to geocode that. And we could see that it was able to find it, which is good because I live there, so hopefully it exists. I see a particular position. I see information about the address, and I did Lafayette, Louisiana, and recognized that that was the United States. It was able to parse out the state, even the county, and also determine a postal code. That also gives me a basic score, which could be useful for determining, essentially how well it was able to find it. So if your user put in something totally crazy, you could say, you know what, if the score came back real low, I'm just not going to show it. You have that particular option in terms of what you present back to the user. If I were to change this to, let's say, New York City, and I'll leave it just like that and see how well it takes it. And it nicely figured out that I probably want the one that is in New York. And you can see that is that result right there with a different latitude and longitude than the one in Louisiana. It's quite a bit farther away from where I am right now. Now I'm going to show you another example of the Geocoder API. And what I'm doing in this one is specifying another attribute for where I am. And all this is going to do is try to give the geocoder some context in terms of my location and what I'm looking for and try to find better results. Now in this case, it should return the exact same thing, and it did, but it also returned a distance value. So if I was looking for something like New York City, I could see how far away it is. Now in this case, the value I entered is very close to the latitude and longitude. So the distance, which is in meters, is going to be pretty small. If I change that to New York City, let me type that again, New York City, that distance should go quite a bit higher. And as you can see, it did. And again, that's meters. So being that I'm an American, all I know is miles. I can't tell you how far away that is, but I'd guess about 1,000 or so. Right. One more second. So just to show you that you can use this in code, I am going to show you, there we go. So this is an example of a simple HTML file. This one is using some Vue.js. And what I did was I embedded some code to call the REST API from a client-side application. So all I'm doing is I'm taking some input, I'm calling the geocode API endpoint, and I'm going to look at the results and map them out on the page. So I'll show you this demo. And it is not this one. It is this one right here. Okay, so I made a default occasion so I wouldn't have to type, but this should give me some results. And I have the location for every single result. And because of that, what I'm doing here is using another one of our APIs. We call this the map image API, and it creates a static map of a location. Because I'm rendering a couple of different results here, I didn't want to use one map. I wanted to show each result and a map for each item. We do obviously have interactive maps. I'm going to show you an example of that in a little bit. So you have options in terms of how you want to show this. So that is geocoding. I'm going to take a sip of water real quick before we move on. So I showed you, where is something. Well, the reverse of that is going to be what is at a particular location. And we call that, obviously, reverse geocoding. And that basically answers the question of, given a particular location, what can I find there? Again, I'm going to start off with a base URL and then add my API key and then pass the attribute at equals lat comma long. So a real example of that could look like this. And again, typically you would have the real key in there, but that is a real latitude and longitude. So again, I am going to hop into Postman real quick and show you a call to reverse geocode. So this URL just, excuse me, matches what you saw on screen. I'm basically just passing my key. I'm passing a latitude and longitude, and this is going to tell me what is at that location. I'll hit send, and I can see that this is actually someone's house. This is not my house, but I could see a title, I could see the address, I could see the distance from the input I gave, which is pretty darn close. And essentially, if I start modifying this at value and just essentially, start moving east, for example. So -92, we go to -82, that moves us east. We should see something in Florida. So no big surprise there. And then if I go one more, I should be in the ocean and have nothing returned. And there we go, that makes sense. So if you do try to reverse geocode something that's like empty, essentially the ocean in terms of points of interest, then you're gonna get no results found. So that was essentially the REST-based examples of using those APIs. And you obviously can use that in JavaScript. I use the fetch command in my JavaScript function, example. All modern browsers support fetch. If you had something like jQuery or Axios, you could use that as well. Basically, there's just nothing special when using REST, which is what you like. You like things to be simple. However, most of the time, you're probably going to be integrating it with Maps.js, and that is our interactive maps. I'm going to show you an example of what that looks like. Now, I'm not sure if people in the audience have seen our mapping library. I will be showing a full example, but I wanted to start a bit simple. But given that you're in a JavaScript file, you make an instance of a platform. From that, you get the search service, and you can see that on this line that I'm highlighting right here. And then after that, you can just call .geocode on it, and you can see I'm passing a queue parameter, and then I have a callback function. In this case, I am going to ask the map to add a marker for each result found. Reverse geocode looks pretty much the exact same. You once again get your service from the platform object, and this time you call reverse geocode instead of geocode. And you can see instead of passing a queue parameter, I'm passing at and specifying a location. So let's take a look at that particular one. I'm going to show both examples and I'll show some code. So the first one is JS Geocode. All right, so I have a map, and all I'm going to do is enter a couple locations, and it's going to geocode and find that for the map. So I have Lafayette, Louisiana already typed in. I hit geocode, service ran, and it added a marker. And if you were curious, that is where Lafayette is in Louisiana. If I zoom out a bit and try New York City and geocode that, and zoom out a bit more, we can see how far away New York is. And I could type other places here as well, and it'll just keep adding markers. So the code for that, let me kind of move around a little bit here. So there is some boilerplate code for adding our maps library. You can see this in line 46. We create some layers, we create a map object. I centered my map on Louisiana, that's where I am, so I made it easier to find stuff. And I added some default behaviors so I could scroll and zoom and stuff like that. Once again, I'm using Vue.js for this application. You absolutely don't have to use Vue. You can use React. You can use vanilla jQuery, Angular, whatever you want. So I have that button, which was up here. That is what is firing off the call based on my input. In this case, it's running a function called geocode. And all this does is use that service object, and much like I showed you on the slide, runs the geocode method, takes the input, and then for every item found, it adds a marker. Now, the reverse of that will be if I click on a location, and I'll click around Louisiana, it's actually going to tell me what is there. Now, in this case, I didn't do anything fancy with it. I took the result and just kind of pasted it onto the HTML page. In a real application, you absolutely would not do that. You would do something a bit nicer, but this shows you essentially the data returned from the call. If I were to zoom in and go to, let's say, New Orleans, I do know where New Orleans is, click somewhere in there, and we'll get some random house. The code for this is going to be really, really similar, as you could probably imagine. Again, using a Vue.js application, but instead of doing the .geocode, I am going to be doing reverse geocode. In case you're curious, I added a tap event to the map. That event gets passed where on the screen it is, and from that, I could turn that into a latitude and longitude. Once I have that, I can use that with reverse geocode. And again, in my example, all I did was take that result and print it to the screen. You can definitely do something a bit nicer with it. So that is our geocoding and reverse geocoding. Both of them take a few more additional parameters. Again, our API reference will help you out on that. But what I've shown so far is typically all you're going to need to add those features to your applications. So let's pick it up a bit. So we talked about, where is a particular location and what is at a particular location. Let's talk about what is around here, what's around a particular location, or basically search. I'm going to break search down into three main sections. We have discover, we have browse, and we have suggest. So let's start off by talking about discover. And as you look at that pretty picture, I'll drink some more water. All right, discover. Basically, this is a good API to use when you're working with free-form search of some type. So you have a user, they're looking for something, and you basically need to match that against some particular type of location. It's also good for handling matching a chain, so McDonald's, Taco Bell, things like that. It will be based on a location. So I am either at a point or I'm concerned about a circular region or a square region, and I want to search within there to find items. Once again, I'm going to show you the URL, and then we're going to play with it a bit. This is the base URL for the REST-based API. Once again, you will add your API key. You will give it a position to start off with, and then specify the term or the thing that the user is searching for. So in a real application, it would look like this, again with the key change to a real value. I'm going to give it a location, and my Q value is going to be Taco Bell. I'm a bit fascinated with Taco Bell, I will not lie. So let's take a look at some examples of this. All right, so for my first one, this is the URL that I showed on the slide. This is the location I'm using, and this is the value I'm searching for. Let me run it again. I already had the result in there, but we'll pretend it wasn't. And what we're saying here is a list of items that match that query value. And no big surprise, the first one is Taco Bell. I get things like the address, both broken down and put into different pieces, as well as a label, which is good for printing. I also have the exact position. This access value will actually tell you where you need to be to get into this particular building. I get a distance based on the @ value, and a lot more information depending on, of course, what you're looking for. But in this case, I have a phone number, I have a fax number, in case I want to go back in time and pretend I'm still faxing, email address. We also have information about about the open hours. This will be set in 2 different ways. You'll have like an English version that you could print, as well as more of a data-centric version that you could see under the structured value. We also tell you if it's open or not. Certainly, things are a little bit, a little bit chaotic now. Some places are open and closed at different hours than they may have logged in the past. So for the next month or 2, you may want to call before you actually go to this particular place. But that is an example. As I scroll down, I can see more Taco Bells. We could play with this a bit and see how well it handles some bad input. Like, for example, if I don't put a space in Taco Bell, and we could see it actually handled it really well. If I switch that -92 to 82, and if you remember, that was somewhere in Florida. I'm assuming they have Taco Bells in Florida. And they do. Yeah, they have one in McElhenney. I'm probably saying that incorrect. But we could also change this to something like Elm Street. I'm sorry, like a hotel. If I say Marriott, that's a better example. It's a good brand name. We should see what hotels are nearby. And for some reason, we have a large number of hotels in Lafayette. We can even see one near the airport. I'm going to try. I have no idea how well this will work, but I'll just try airport and see if it finds. Let's see. Well, okay. As you can see, it found a hotel first. Let's see if it finds Lafayette Regional. It found an airport road, and it found another hotel by the airport. That's interesting. Oh, it did find a control tower. I did not know that that actually had a address, but it looks like it does. So I'm going to call that close enough and be happy with that. So in my next example, I basically, kind of modified it a little bit. And instead of just saying, I'm at a particular location, I'm using a radius-based, circle approach. So in this case, I've given a specific latitude and longitude, and that's here. Also note that I'm using the parameter in, not at. And I've also given a radius, in this case, 800 meters. When I run this, I get 1 Taco Bell. So basically, in a circle around this particular location, only 1 Taco Bell is found. If I were to greatly increase that radius, I should see many Taco Bells. And for the heck of it, let's do 80,000 meters and see how many come back. The API does return does support a limit. So, if you're worried about too many results being returned, then you have a way to prevent that from happening. So that is the discover endpoint. Now let's talk a bit more about browse. And by the way, if the distinction between these two is not super clear, I have a slide coming up in a little bit that will hopefully make that a bit easier for you. So when we talk about browse, we're really kind of talking more about category type searches. So, I'm not looking based on input, like I'm not typing in Taco Bell. Instead, I want to find Mexican restaurants or Tex-Mex restaurants, or I want to find a bank. I'm looking for a particular type of thing. This endpoint does support passing a name as well. So if somebody told me, hey, I went to a great Chinese restaurant that had Bell in the name, I could actually use this API to try to find it. It also supports, if you want to, you can actually ask it to return everything around a particular location. I'm not really sure how you would use it, but that's an option as well. Now, one thing that I want to say about the category system is that it is extremely detailed, like shockingly deep in terms of how cool it is. So it has two main category systems. I'm going to talk about the first one here. The first one is a 3-level category system where level 1 could be kind of broad, eat and drink. Level 2 is a restaurant, and level 3 is fine dining. So we definitely support more than just food stuff, but essentially we allow you to be, kind of vague, looking for a financial institution, or a bit more specific. I'm looking for a bank. I'm looking for a tax advisor. I'm looking for a financial lawyer or some such. So we have that category system, and it's nice and broad and allows you to get as precise as you want. But then we have a whole separate system just for food. And this food system is like crazy. I mean, it's crazy in terms of how deep it goes. So it also has a 3-tier system. And it's so deep that what I'm showing you on screen here, this is just the options under Asian. So Asian's like a level 1 thing. Underneath Asian, I can do everything that you see on screen here. And this is just level 2. If I go to level 3, so for example, Asian/Chinese, there is about 15 or 16 different Chinese options. Now, I'm lucky enough to have been able to go to China and realize there are different types of Chinese food than what you'd see in a typical American Chinese restaurant. So I looked at this list, I recognized maybe like 3 of the options here, but if you know a very specific subset of Chinese food that you want to get, our API would support searching just for that. So that particular endpoint, browse.search.hereapi.com/, et cetera. Once again, you will pass the API key. You'll give it a location, and I keep using the @one. As you saw previously in Postman, we do support circular and rectangular searches as well. And then I will pass my list of categories. So a real example could look a bit like this. So I have specified a particular and I have specified 2 categories. What are those categories? One is Chinese food and one is Cuban food. And I know that because our documentation has all this spelled out. So for example, under places category, which again covers everything, banks, et cetera. So you have eat and drink, going out entertainment, and sites and museums and so forth. Under the food one, I could also dig into that. And these first 7 are the kind of broad top level food organizations. And I mean, I'm going to scroll quickly here. You won't be able to read, but I just want to like overwhelm you with the different kinds of options. So if you like food, and I like food, you can get very particular in terms of what you're looking for. So let's look at an example of that. And again, I'm going to go to Postman, open up Browse, and pay no attention to what you see in the screen. But these are the values that I had on my slide deck. Again, looking for Chinese and Cuban. And if I run send, I can see my results. Now, if you're like me, you see that first result, Hong Kong wigs, and you probably think that is wrong, or API is wrong. I saw that. I looked them up on Facebook, and on Facebook, they advertise themselves as being both a beauty parlor and a Chinese restaurant. Now, I'm a little scared to go try that, but in this case, our API is reporting back what they said. So you get the address again, and so this data format pretty much matches exactly what you saw with the last API, which is good. So we are consistent in terms of what you get back. I will point out, you see all of these different categories. Unfortunately, right now, if you want to know what they are, you have to go to a documentation. I have filed an enhancement request with the engineering folks to start returning labels for these categories, for both categories and food type, so that you can actually show that to the user or do some simple filtering. So while I know that I could look this up, and you know what, we'll try that. This is not something that you want to have to worry about when you're writing your code. So let's actually, I'm kind of curious because this place could be kind of cool. Specialty clothing store. And for the heck of it, we'll pick one more. We'll pick 100, 1000, and see what that is. And that is the restaurant. Yeah, and I think they may be fibbing just a little bit on that, but that's what they are reporting. And for the heck of it, we'll take a look at one more here. They picked 6 different categories, so they really, and I picked the same one again. Let's try 96. And that one looks like, oh, let me pack the whole thing in. I apologize. That's what I get for trying to cut corners. All right, let's find that one. That's a specialty store. Okay, so it's a specialty store. It's a specialty apparel store. And apparently, also, it happens to be a Chinese restaurant. So that's pretty cool. All right, so that was that demo. So I had mentioned that I was going to talk a bit about Discover versus Browse. To do that, I'm actually taking something straight from our docs because I thought it did a pretty good job of explaining it. So I won't read right off the slide deck, but what point this is making is that Discover is more for when a person is typing something in. So they're typing in the words Taco Bell, whereas Browse would be more where, I know the user wants to find food, so I can use that particular category to search for that. Obviously, there's use cases, I think, that would apply to both of these, and you can definitely play around and see which one works best in your application, and then obviously go with that. A great example of a specific input where New York Pizza under Discover is going to look for restaurants in New York City, whereas Browse can be a bit more strict and try to find a place that's named that. So that's a good example of when you would use one over the other. This also impacts the sorting. So because Discover is taking user input, it's going to want to sort by how well the results match what the person typed in. But for Browse, because again, it's more machine-centric, more direct, it's going to be sorting by distance. Now, don't forget, when you get those results back, you're free to kind of resort them based on what you think makes sense. Now, the last part of search is not really search per se. It's more of a way to kind of help you build auto suggest forms. So with suggest, we are talking about auto suggest. And this is that common user input where a person begins typing. And as they type, things will come in to allow them to kind of pick one and skip ahead. One thing about our particular suggest product is that we're going to return both kind of general results as well as results that are things to query. So if you're typing something in, we may say, oh, I think you want to search for this. We will return those type of results along with general results as well. So that probably didn't make great sense. So let me actually show you this in action, and hopefully you'll get what I'm talking about. And by the way, like I said earlier, all this code is available to you. Just drop me a line, send me a DM, and we'll test it. I'm going to start typing, and as I type, we can see the results change. If I look at REST, what this is going to do, let me actually switch to Postman and actually show you the data coming back. So when I search for REST, it's actually going to return a category query, which is a way of saying, hey, you probably want to search for this in particular. It's going to return this, and you can tell by result type, along with generic places as well. So we have takeout, express, restaurant, and restoration movement, etc. So this is basically just kind of showing you different types of results that come back from that value. That demo that I just showed was basically the exact same thing, but tied up in a simple Vue.js application. Now for mine, I sent the input as soon as you type. You can also wait until the user has typed 3 or 4 letters before you start rendering the results. The API will support anything. It will support one value. It should return 1. We'll confirm that just to be sure. And it did, but obviously it's really, really kind of vague when you type in one particular letter. I do note though, I am passing my location, so rain is a valid match for R based on where I am. But again, the API supports from 1 to many. You know what your users may want. You know the types of results that are coming back, so you can make that judgment call on when you want to start asking the API to send stuff back. So this also, let me get back to my slide deck. This particular feature also has integration with Maps.js. I didn't build a demo for that, but I'll say that all of the search service stuff, all the Maps integration, it is all documented. We have an API reference for the JavaScript library, just like we have one for the REST-based APIs as well. So I'm going to show you that real quick. If you go to developer.here.com, you'll see one of our products is Geocoding and Search. And from here, you can go into the documentation. And once you've done that, you can pick JavaScript or REST. And again, the JavaScript part will be more focused on people building interactive maps. So I'm going to go into the REST aspect. And from here, you have a guide, you have release notes, and you have the API reference. So there's a lot of cool example here, some good tips as well. You can also look at the API reference. You know, I mentioned that I didn't show every single aspect of those APIs. So if you want to take a look at what else is supported, you can do that. And so that is pretty much it. And I am absolutely open to some questions. And y'all had some great questions last time. So I hope y'all do again as well. And I have my Twitter address on there. So again, if you think of something later, send me a DM and I'll be happy to try my best to help you out.
Thank you very much, Raymond. It was a great presentation, very informative. I personally learned a lot. I'm going to open it up to the attendees. If you have any questions, anything was not clear, or if you're curious about any sort of integration with other services, please feel free to raise your hand or and speak, or yeah, just write down your question in the questions board. Okay. Raymond, I don't think there's been any questions so far. Just gonna give it another minute or so.
I can definitely wait a minute or so.
Yep. Okay, there's no question. Raymond, is there any sort of a use case or sort of integration between these services you explained to us today or other services that can people potentially be use during the Hack for Better Days hackathon to possibly build applications for coronavirus? Can you
Well,
think of any?
definitely. So I am pretty darn sure that medical is a category. Let me take a quick look here. So yeah, hospital or healthcare facility. So being able to find your nearest hospital, getting the contact information, being able to map that, I think that could be pretty useful. And certainly mixing this with the interactive maps, like I showed in one of the earlier examples, could be a powerful integration.
Yeah, right. And do we have the like aged care facilities and stuff, like to highlight potentially the vulnerable communities?
I'm sorry, what?
The aged care facilities, like the retirement homes or like the elder where elderly. Uh, there's a nursing.
Yeah. There is one for nursing home, and there's also one for hospital. You could map, for example, how close nursing homes are to hospitals. There's also ER rooms that could be pretty darn important as well.
Yep.
There's also the government section, which could be important.
Yeah, absolutely. Yeah, very cool. Yeah, I've got no other questions.
All right.
Michelle asked something. I can't seem to see it. Just give me. Adil has raised his hand as well. Adil, go ahead. You're on mute.
Hi. Actually, I want to know from where I can get a data regarding the COVID-19 data set.
Did you get it, Raymond?
Yeah, the data sets. Isn't that? I honestly I don't know. I know that we have a resource for that. I'm going to guess at the there we go. Yeah, I know I visited. So for our information, we have a webpage up at developer.here.com/COVID-19. I don't want to promise we have data sets here, but we do have a lot of information here yet and resources. So I would go there.
So can you suggest something for making a map for COVID-19? Do you have any suggestion for that, which can help me to build something better?
Are you asking? You said information about the form of the maps.
Yeah, actually, I'm asking do you have any suggestions for making a build a map hackathon? I mean, like what I can use, which type of data sets I can use.
Well, certainly, being able using the browse APIs to find hospitals, to find medical resources based on a location, that would be one place you could start.
Okay, thank you, sir.
Yeah. That was pretty
Yeah,
much it. Go ahead. Sorry.
yeah, that's it. Thank you so much.
You're welcome.
You're welcome, Bill. Yeah, Michelle's question, I think she found the answer herself, which is good.
Cool.
Yeah,
Okay.
yeah, Raymond, there's no other thing. Do you have any final remarks before we close the webinar?
Just that, remember, you could sign up for free. There's a very generous free tier. You don't have to give a credit card, so it's real safe to play with. And we are all on Slack. We being here people, we're very active on Slack. If you join our Slack group, we typically provide support pretty much all day long. And at the bottom of the developer.here.com site, at the very bottom, you can see a link right there for Slack.
Right, and this Slack is different from the Slack for the hack. So that's our developer support. So yeah, just bear that in mind.
Okay.
Okay, join me to thank Raymond for his excellent presentation, and thanks to all the attendees who attended this webinar. I hope you learned new things that you can use within your projects. Yep, you take care and good luck with your projects, and we'll see you in the next webinars. All right, thanks. Thank you all. See you next time.